Welcome to 5.4, sum and difference formulas for trigonometric functions. As you can see, we've got some rules here that we need to be familiar with. Not too bad to get used to here, to memorize. Sine of a sum of two angles is sine of the first, cosine of the second, plus I often go sine, cosine here and switch the angles. So this could be sine of v times cosine of u. So I go sine, cosine plus sine, cosine, but you have to switch the angles. Angle u, angle v, angle v, angle u. Sine of a difference, the only difference is the difference. Cosine of a sum, two things switch from cosine to sine. First we group the cosines, and then we group just the sines, and then addition becomes subtraction. If we know that one, memorizing the second one, not too bad. The only thing that changes here is the minus becomes a plus. Minus becomes a plus. Tangent of a sum is sum of the tangents over 1 minus product of the tangents. And tangent of a difference, pluses become minuses, minuses become pluses. So obviously you'll be referring back to that for a bit. I believe if you go through this, if you go through the notes, by the time we're through the notes, by the time you're through the assignment, you will just naturally have ingrained those in your brain. If not, you got to put a little bit of time into memorizing these things. So the author's trying to make a point on number 10 and 12 that we're going to take a look at. If you can look from A to B, it looks like, well, how about if we just distribute sine into here and treat it that way? So let's start with A, but I'm going to start with A by going ahead and treating this. Let's see, 405, well, that's 360, that's a 45, and 120s, we know those are good angles. I'm going to go ahead and treat this with our sum rule for sine, which says this would be sine of 405 degrees, cosine of 120 degrees, plus sine of, switch them, 120 degrees, cosine of 405 degrees. Well, this is 45 degrees beyond a full revolution, so this is really just sine of 45 degrees, cosine of 120, plus sine of 120, cosine of 45 degrees. It's just beyond a revolution. So we'll zoom in on here a little bit, get a little easier viewing of this. So let's take a look. Here's our 45 degree triangle right here, where we're dealing with ones by square root of 2's. And here's our 120. Right here, it's tall. This is a 1 by 2 by square root of 3, but it's to the left. So sine of 45 is 1, y on r, 1 on square root of 2, times cosine of 120, x on r, negative 1/2, plus sine of 120, square root of 3 on 2, times cosine of 45, 1 on square root of 2. And that equals, let's see, I get negative 1 on 2 square root of 2 plus square root of 3 on 2 square root of 2, or negative 1 plus square root of 3 on 2 square root of 2, or let's go ahead and simplify that. Multiply square root of 2 on square root of 2 here. Multiply by 1, and I get negative square root of 2 plus square root of 6, all on 2 times 2, all on 4. Okay, whereas, let's check. So there's A. There's our solution for A right there. B, now we want to find sine of 405. Well, that's sine of 45 degrees plus sine of 120 degrees, as if we could just distribute this and come up with that answer. Let's see. Sine of 45, y on r, 1 on square root of 2, plus sine of 120, square root of 3 on 2. If I get common denominators here, that would be square root of 2 times 2. It's my common denominator. This had to be multiplied by 2 on 2, plus this had to be multiplied by square root of 2 on square root of 2, square root of 6. Let's rationalize this guy, times square root of 2 on square root of 2, and we get 2 square root of 2 plus square root of 12, which is 2 square root of 3, all on 2 times 2, 4. We could reduce by 2's and we get square root of 2 plus square root of 3 all on 2, but we don't get that. So the point they're trying to make here is you're not going to get the same result by going ahead and just distributing this thing. And we'll find similar things to happen to us here. Now, cosine of a sum, do you remember it? It's like sine of a sum, but two things change. Instead of sine, cosine, it's cosine, cosine, sine, sine, and it's minus. So here we need cosine pi on 4, cosine pi on 3, minus sine pi on 4, sine pi on 3. And I'm going to work under the assumption that we can all draw the triangles right here. Cosine pi on 4 is 1 on square root of 2. Cosine pi on 3 is 1/2. Minus sine pi on 4 is 1 on square root of 2. Sine pi on 3, however, is square root of 3 on 2. You can go through the triangle building process for that if you need to. So this is 1 minus square root of 3, all on 2 square root of 2, or if we rationalize square root of 2 on square root of 2, we get square root of 2 minus square root of 6, all on 2 times 2, 4. And if you notice, that answer looks a lot like this answer over here, and that's going to be another topic for another time. But there's A. Then B, we're just supposed to find cosine of pi on 4 plus cosine of pi on 3. Cosine of pi on 4 is 1 on square root of 2. Cosine pi on 3 is 1/2. That would be 2 square root of 2. That's 2 plus square root of 2. Had to multiply this by 2 on 2, square root of 2 on square root of 2. Or if we multiply by square root of 2 on square root of 2, I get 2 square root of 2 plus 2 on 4. And reduce, I get square root of 2 plus 1 on 2, but I do not get that. The whole point of this exercise is just to show you common mistakes that are made. If you have a problem like this and you distribute cosine, I'm not going to give partial credit for it. I don't care what you do beyond that. This is a function. This is not cos times the quantity. This is cosine of. You don't distribute functions. Okay. One of the things that the sum and difference rules allow us to do is find well, let's take a look at this 255, and then I'll come back to that thought. 255, well, it's 270 to right here. 270 to there. 255 creates a 75, 15 right triangle. And we're actually able to find the exact values of those. That's kind of what we just did up above in the A portions for 10 and 12. We're able to find the exact value of 15-degree angles. And eventually I'm going to show you a really sweet shortcut to that. But find the exact value of sine, cosine, and tangent of the angle. So sine of, I don't know how to deal with 75 15s yet, but I know how to deal with 300 and minus 45. So sine of 300 degrees minus 45 degrees. Sine of a difference. Do you remember how we do that? Up above. Sine of a difference is sine cosine minus sine cosine, but you switch the angles. So this could be sine of v, cosine u, of course. That's just my habit for doing these. So that gets me sine of 300 degrees, cosine of 45 degrees, minus sine of 45 degrees, cosine of 300 degrees. Now the 45, I can work from memory on that. I know my sine and cosine of 45, no big deal. The 300, I'm going to build that one right here. 300 is 60 degrees shy. There's a 1, 2, square root of 3, negative. If you need to build the triangle for 45, great. So sine of 300, y on r, negative square root of 3 on 2 times cosine 1 on square root of 2, minus sine of 45, 1 on square root of 2 as well, but cosine of 300 is 1/2. And here I get a negative 3 minus 1, or negative square root of 3, excuse me, minus 1 on 2 square root of 2, or multiply by square root of 2's, I get negative square root of 6 minus square root of 2 all on 4. And once again, take a look. That's a 6. Bad 6, but it's a 6. Has kind of the same feel of what we were just looking at on these previous problems. Okay, well, let's go cosine. Cosine of 300 degrees times cosine 45 degrees minus, wait, it was a minus here. Cosine of a minus is cosine, cosine plus sine, sine. So plus sine 300 degrees, sine 45 degrees. So cosine of 300, x on r, 1 on 2, times cosine 45, that is 1 on square root of 2, we did it above. Sine of 300, x on r, negative square root of 3 on 2, times sine of 45, 1 on square root of 2, gives me 1 minus square root of 3 all on 2 square root of 2, or multiply by square root of 2 on square root of 2, square root of 2 minus square root of 6. There's that repeating little look we have, all on 2 square root of 2 times square root of 2, 4. And tangent of 300 degrees minus 45 degrees is tangent of a difference is the difference of the tangents over 1 plus the product of the tangents. So it's the difference of the tangents, tangent 300 degrees minus tangent 45 degrees over 1 plus tangent 300 times tangent 45. Tangent of 300, y on x, negative square root of 3. I'm going to put it over here. Negative square root of 3. Tangent of 45, that's 1 on 1, minus 1. All on 1 plus tangent of 300. You know what? It's just this again. Tangent of 300, negative square root of 3 times tangent of 45, 1. So we get negative square root of 3 minus 1 on 1 minus square root of 3. And at that point right now, we could go ahead and rationalize this. I want to show you something real quickly here. So we could go ahead and use the conjugate of the denominator, and I'll leave that to the reader if you want, but I do want to show you this. We know that tangent is sine on cosine. Take a look. If I put this on this, the on 4's cancel, and I get negative square root of 6 minus square root of 2 all on square root of 2 minus square root of 6. And take a look what would happen if I would multiply this by square root of 2 on square root of 2. We'd get exactly to there. So again, to rationalize this, we'd multiply by 1 plus square root of 3 on 1 plus square root of 3. But if we're finding sine and cosine, we can do this on this and get to there and then simplify that. Okay, 5/12. We can't find the exact value of 5/12, but 5/12 could be split into 3/12 pi plus 2/12 pi, which is pi on 4 plus pi on 6. 3/12 plus 2/12. We can find our 5/12 pi right there. Pi on 4 plus pi on 6. So sine of pi on 4 plus pi on 6 is sine of a sum is sine cosine plus sine cosine, but switch the angle. Sine pi on 6 now, cosine pi on 4. And if we need a pi on 6, since we haven't talked about that one yet, we can put that one in here. Here's 1, 2, square root of 3. So sine of pi on 4 from above, 1 on square root of 2, cosine pi on 6 x on r square root of 3 on 2, square root of 3 on 2, plus sine pi on 6, 1 on 2, cosine pi on 4, 1 on square root of 2, and I get square root of 3 plus 1 on 2 square root of 2, or there it is again, multiply by square root of 2 on square root of 2, and we get square root of 6 plus square root of 2 all on 4. Now there's that same pattern with the square root of 6 and a square root of 2 on top. And 4's on the bottom. Same pattern. Okay. Cosine pi on 4 plus pi on 6. Cosine of a sum. Do we remember what it is now? Maybe not yet, but hopefully. Cosine, cosine, minus sine, sine. Cosine of a sum is cosine, cosine, minus sine, sine. So we get cosine pi on 4, cosine pi on 6, minus sine pi on 4, sine pi on 6, cosine pi on 4, 1 on square root of 2, cosine pi on 6, square root of 3 on 2, minus sine pi on 4, 1 on square root of 2, sine pi on 6, 1 on 2. And you notice we keep getting these common denominators, and that would be the norm for these problems. And that gets me square root of 3 minus 1 on 2 square root of 2, or square root of 2 times square root of 2 on square root of 2, square root of 6 minus square root of 2, all on 4, and there it is again. And now we know that we could just put this on this and reduce to get tangent. Or we could go through the tangent process. I'm just going to say tangent of pi on 4 plus pi on 6 is this on this. The on 4's cancel. Is pi on 6 plus pi on 2 over pi on, what did I say? Sorry, square root of 6 plus square root of 2 over square root of 6 minus square root of 2. Wow. Which is square root of 3 plus 1 on square root of 3 minus 1. And let's go ahead and rationalize that just for the sake of it, since we didn't do it on the last one. Let's go square root of 3 plus 1 with the conjugate, square root of 3 plus 1, and we get, let's see, I'm going to get a 3. I'm going to get a square root of 3 and another square root of 3. I'm going to get a 1. In the denominator, good things happen. I get square root of 3 times square root of 3, 3. I get a plus root 3, but a minus root 3 and a minus 1. So we end up with 4 plus 2 square root of 3 all over 2, or 2 plus square root of 3. And I'm going to tell you, sorry if that was cut off. Go back, follow the words. I just looked up at my screen and realized that I was off the screen. If you go back and rationalize this, I will tell you you're going to get something that looks like that. There's going to be a 2, there's going to be a square root of 3. It's just the pluses might turn into minuses. And I'm going to show you a really, really cool shortcut to being able to do these, where you can get a problem like this. After we work through this assignment, you can get a problem like this and you can jump right to the solution. Okay, now we've got some things. This has a familiar feel to it. Notice we switch the angles. This is sine cosine plus sine cosine, but switch the angles. And we're supposed to write the expression as the sine, cosine, or tangent of the angle. Now we're using our rules in reverse. That has the feel, or is modeled after this. It's just working backwards. There's sine of 110, cosine of 80, cosine of 110, sine of 80 equals sine of 110 plus 80. Now, I'll be honest, there won't be many times that you actually work these formulas backwards in real world type problems, but it's good gymnastics. So do we recognize this one? Cosine cosine minus sine sine. Cosine cosine minus sine sine. Have we seen enough that we recognize which sum or difference rule this is? Cosine cosine minus sine sine is cosine of sum. So this becomes cosine of, add the angles together, 0.96y plus 0.42z, and it seems like we should be able to do something with that. Seems like we should be able to do something with that, but we are stuck at that point. How about tangent minus tangent on 1 plus the product of the tangents? So it's the difference of the tangents over 1 plus the product of the tangents. The difference of the tangents over 1 plus the product of the tangents is tangent of a difference. So this is tangent of 154 degrees minus tangent of 49 degrees. See, in this one it sort of looks like they're distributing, but it isn't distributing because we do get the tangent u minus tangent v, but then we get the whole denominator. So you cannot just distribute these things. Shouldn't have put a tangent here. Should just be the 49. So we end up with tangent of 95 degrees. Apologies for that. Find the exact value of the expression. Okay, well, I don't know. I haven't ever worked with pi on 16 before to find the exact value. But here we have cosine cosine minus sine sine. Cosine cosine minus sine sine. Do we recognize that one? The angles stay the same. Cosine cosine minus sine sine of the same angles is cosine of a sum. So this becomes cosine of pi on 16 plus 3/16 pi, or cosine of 4/16 pi, or cosine of pi on 4, which of course we've seen it and seen it, 1 square root of 2, which is 1 square root of 2, or square root of 2 on 2. Surely by now we're recognizing this. Tangent of a sum over 1 minus the product of the tangents. The sum of the tangents over 1 minus the product. The sum of the tangents over 1 minus the product is tangent of just the sum. So this is tangent of 25 degrees plus 110 degrees, or tangent of 135 degrees. That has a familiar ring to us. 135 is 90 and 45 more. That's a 1 square root of 2, but that's to the left. And tangent is y on x, and y on x is 1 on negative 1. Okay. Let's take a look at these two, and then we're going to split this into a couple different videos. In exercise 43 and 46, find the exact value of the trig functions expressions where sine of u is 5/13 and cosine of v is negative 3/5. Both u and v are in quadrant 2. That is begging us to draw a picture. Here is u. U is in quadrant 2, and not going to try to draw it to scale. Maybe I should. Y to r is 5 to 13, and a little Pythagorean work gives us negative 12 there. Here is v. It's in quadrant 2. X to r is negative 3 to 5, and that gives us 4. So tangent u plus v, and here's where our brains stop, because we want to say, oh, well, it's just tangent of u. Let's see, 5 on negative 12 plus tangent of v. I just distributed tangent. Don't do it. Tangent of a sum, do we remember it? Tangent of a sum is the sum of the tangents over, careful with your v's there, over 1 minus the product of the tangents. Now, tangent of u, here's u, is 5 on negative 12. Plus tangent of v is 4 on negative 3, all on 1 minus tangent u, negative 5/12 times tangent v, but it's just this thing again, times negative 4/3. Lots of negatives going on here. Let's see, I get negative 5/12 minus 4/3 all on 1 minus minus minus, that's minus 20/36. And I know I could get common denominators, or excuse me, I could get common denominators, smash this, common denominators, smash this, flip and multiply. But I'm just going to multiply by my least common denominator out of all these. And we could reduce the 20 on 36. Let's go ahead and do that. Let's go ahead. Negative 5/12 minus 4 on 3, all on 1 minus. These both reduce by 4 to give me 5/9. Now, what's my least common denominator out of this, this, and this? Well, these would be 12. 12 and 9, they don't both go into 18. They won't, nope, it's 36. I'm going to multiply top and bottom by 36. And let's see, when I distribute, 36 and 12 reduced to 3 times negative 5, negative 15, minus 36 and 3 reduced to 12 times 4, 48. 36 and 9 reduced to 4, 20. I get negative 63 all on 16. Okay, working with the same U and V here. Sign of a difference. Certainly by now you've got it. Sign of a difference is sine cosine. Sine U, cosine V. What comes next? Minus. Sine, switch them. V, cosine U. I know the book shows it a little bit differently. This is old habits die hard. This is my habit, is just to go sine, cosine, but switch the angles. Same results. So sine of U, y on r, 5/13. Cosine V, x on r, negative 3/5. Minus sine of V, 4/5, times cosine U, negative 12/13. And I realize my 5s could reduce here. Is there a payoff in doing that? I don't think so, because notice we have nice common denominators. This gives me negative 15 minus minus plus 48 all on 65, or I get 33 on 65 does not reduce. And we're going to call that part 1. And we got some, well, I'll get the second part up soon, but that should keep you busy for a bit. Promise you got a really good shortcut coming to these 1575s or 75, 15, 90 reference triangles. And make certain that you're sticking with this. Important stuff as we're moving forward. I throw the assignment up here so you can at least see the beginning of that. I do have a couple more pages. This is our 5-4 assignment, and 1 through 8 at this time is optional unless you hear otherwise, but you should be able to get a good jump start on this assignment. Good luck. Let me know what I can help you with.